All right, so we've got bundle of trash initially at rest, pulled across the ground, angle 25 degrees. Okay, we have the acceleration, 0.30 meters per second. Coefficient of kinetic friction, mu is 0.5, magnitude of force of tension in the rope. All right, force diagram, I'll draw it down here. Okay, we've got our axis. Okay, we've got force of gravity, as we always do. We've got the applied force, they're calling F prime, 25 degrees. Must be friction. And there's still some normal force. All right, so we want to find the force of tension in the rope, F prime, they're calling it. So let's go ahead and set up Newton's second law in each direction. Some of the forces in the X goes MAX. Some of the forces in the Y equals MAY. Now, for the Y direction, this is just going to be 0 because it's not accelerating up or down. X direction, we have what we need there. Let's look at the forces in the X direction. We've got the X component of the applied force, which is F prime cos of 25. All right, we've got friction minus the coefficient, which is 0.50 times the normal force, which we don't know yet. It's not simply 150 newtons. That equals 15 kilograms times 0.30 meters per second squared. All right, now some force in the Y direction. All right, in the Y direction, we have F prime sine of 25 degrees plus the normal force minus the force of gravity, which is 150 newtons. Those all equal 0. So from the Y direction, we get that the normal force is equal to, bring the 150 over here, 150 newtons minus F prime times the sine of 25 degrees. So the normal force isn't simply 150, it's 150 minus the Y component of the tension. So we can take that in over here for the normal force, plug this in over here, and then see where we're at. So carry this down, F prime cos 25 degrees minus 0.50 times 150 minus F prime sine of 25 degrees equals, and I guess I'll do that math real quick, 15 times 0.3 is 4.5. And that would be newtons. All right, so we got to solve this for F prime. I'm going to go ahead and distribute this 0.5, right? And that distributes here and here. I'm going to figure out what the signs are here. So cos of 25 is 0.90. I'm in degrees. 0.91, I suppose I should say. So 0.91 times F prime, that's this one, minus 0.5 times 150, which is 75, right? Minus 75. Distribute this to here, but it's going to be positive because it's negative times this. Plus, and sine of 25 is 0.42. So 0.42 F prime equals 4.5 newtons. Now, I probably shouldn't put that unit there because I didn't put any units in here. Well, those are dimensionless. This one has units in newtons. I guess I could put that on there. So now we're going to group like terms. So 0.91 plus 0.42 is 1.33 F prime. And then we're going to bring the 75 over here. equals 75 plus 4.5, 79.5. 5. That does have units of newtons. This one doesn't have any units, so divided by 1.33, divide by 1.33. F prime is 60 newtons. All right, that's the magnitude of the force of tension of that rope. All right, next one here. All right. Force diagram. We'll do, now this is kind of a strange one here. We've got to pretend all the mass is concentrated in the crucifix here. 35 grams or 0.035 kilograms. Let's make an angle of 15 degrees. So we're gonna do this. Force of tension, right? Draw my coordinate system. I guess I should maybe give myself a little more space. We got force of gravity here. This is 15 degrees. It's accelerating. It's accelerating to the left in the way I drew it here. All right, so some of the forces in the X is MAX, some of the forces in the Y equals 0. Okay, so in the X direction, we're gonna have the X component of the tension, so it's gonna be Ft times the sine of 15 degrees equals 0.035 kilograms times A. I'm just going to call it A here because that's what we're going to be looking for. And then the Y direction, we have Ft cos of 15 degrees minus 0.35 newtons equals 0. So the force of gravity is that times 10, 0.35 newtons, and it's negative because it's going down. So the tension's Y component minus gravity equals 0. Tension's X component is what's giving us the acceleration here. All right, so let me solve one of these for the force of tension, and I'll plug it in over there for A. So Ft equals, bring the 35 over here, divided by the cos of 15 degrees. So we've got 0.35 divided by the cos of 15. Force of tension is 0.36 newtons. Put that in over here. All right, so we divide this by 0.035 kilograms, divide this by 0.035 kilograms. A equals 0.36. All right, that's going to go in there, times the sine of 15 degrees divided by 0.035 kilograms. Newtons per kilogram is meters per second squared. So 0.36 times the sine of 15 divided by 0.035 is 2.7 meters per second squared. All right, I'm gonna stop this video here and come back and do the other problems in another video.